Hi, welcome to P4PI, P4 on Raspberry Pi for Networking Education. I'm Professor Noah Zilberman, co-chair of the P4 Education Workgroup, and this video provides an introduction to P4PI. Following videos show how to get started with the platform and discuss the technical details of its implementation. As you probably know, learning by doing is a great way to improve students' understanding of the material and increasing their engagement in the class. While programming exercises and software-based solutions are widely used in computer network classes, they have several disadvantages. First, not everything can be covered by programming exercises, for example, network device architecture. Second, they don't provide a realistic experience of a system, and they obscure many of the challenges of a real-world platform. And worst of all, they are not exciting. Over the last few years, P4 was shown to be an ideal language for teaching computer networks, being both quick to learn and easy to use. What we would like to do is engage students in computer networks by using the P4 language and networking hardware in class. Currently, there are a few options available to those who would like to use hardware targets and P4 in class. First, there are P4 programmable ASICs. However, these are very expensive, costing several thousands of dollars for a single platform, and are either partially or fully closed source. Second, there are SmartNICs. They also cost $1,000 or more per NIC, and beyond being closed source, also require microarchitecture knowledge. Last, there are open source platforms like NetFPGA. These cost about $1,500 and also require some FPGA design knowledge. However, the biggest challenge with these platforms is accommodating for a class of 20 students or more. Consider NetFPGA. A single platform costs about $1,500, but 20 of these will cost about $30,000. Equipping a class can be simply too expensive for most of us. So what would be the ideal platform for teaching computer networks? We would like to have a platform that is low cost, ideally less than $100 or the cost of an academic book in a course. Second, the platform should be easy to learn and easy to use. We would like the platform to be available worldwide and with long-term support. And we would like it to be open source. Now, as we want students to use their laptops, this platform should support wireless connectivity, but also wired connectivity if one wants to use existing lab machines. Obviously, we'd also like to have training materials available and not to start from scratch. Now, for teaching purposes, the performance of the platform is not a goal, and home-level performance is sufficient. Can we get all these in a single solution? And this brings us to P4PI, a platform for teaching computer networks using P4. P4PI is based on the Raspberry Pi 4 Model B board and uses the Tapas compiler. The Raspberry Pi platform has a quad-core ARM processor and supports both wired and wireless communication. It costs $60 to $80. The Tapas compiler is an open-source P4 compiler supporting multiple backends, including DPDK and the V1 model. And P4PI is more than a hardware platform. We provide an open repository, including source code, tools, and reference designs. In addition, there are training materials and community engagement facilitated by the P4 Education Workgroup and building upon the P4 community. The P4PI reference architecture is divided between the data plane and control and management. Two of the Raspberry Pi cores are dedicated to the Tapas FastPass, running the P4 data plane, while the other two cores are used by the operating system and the control plane. Incoming traffic, either wired or wireless, goes through the FastPass, except for management traffic that is directed to the slow pass. P4PI is designed to be used vertically across the entire degree, from an introduction to networking course to advanced networking for postgraduate students. In an introductory course, students can use P4PI to send, capture, and observe packets using only one P4PI and a laptop. A few students sharing a platform can experiment with forwarding between laptops while monitoring traffic. While given a few P4PIs, a capture the flag challenge can be created. A more advanced course or a longer introductory course can focus on P4 and show how a calculator, a firewall, or a router can be implemented. Using multiple P4PIs, it is possible to run interoperability tests. Advanced networking courses can use P4PI to teach about kernel bypass and hardware software co-design. Students can be tasked with reproducing results from research papers or designing their own research projects. P4PI can be used beyond the classroom. It is great for hobbyists who can run a P4 programmable access point in their homes for the first time. Researchers can now use many low-cost P4 targets in their research, and new P4 use cases can be explored in wireless networks, for IoT devices, and even with swarms of P4 devices. To summarize, P4PI is a platform developed for networking education. It is cheap, open, and provides hands-on experience. It also makes P4 available for hobbyists, and you can use it to implement your own crazy ideas. P4PI is now available at the P4 GitHub repository, and we invite you to use it and contribute to it. For more information, please refer to the P4PI wiki and to our other P4PI videos. We hope to see you in the next P4PI event.